Good morning, fifth graders. Mr. Rod here with another math lesson for you today. Today what we're going to be doing is working on classifying some quadrilaterals. Yesterday we started talking about the triangles, and I have the board up here, the hierarchy. And today what we're going to do is we're going to look at not just our three-sided shapes, but instead we're going to look at our four-sided shapes today. So I want to just review kind of yesterday what we did, what we talked about. As we created this hierarchy. Remember, a hierarchy is kind of like something in your address, living things classification. Here, let me see if I can just move this down just a little bit so you can see the bottom of mine. There you go. Or even like your family tree. So the way that a hierarchy works is it works from bottom to top. It doesn't work top to bottom. And what I mean by that is if I look up at the top, I can't say that all polygons. Remember, polygons are any shape that has three sides or more and is a closed figure. I can't say that all polygons are acute isosceles triangles. But what I can do is I can work from bottom to top, and I can say, well, I know that all acute isosceles triangles are isosceles triangles, which means that they are triangles and that they are polygons. So again, all I'm doing is I'm following the lines that I made. And if you get out your sheet that we worked on this with yesterday, you can trace and follow kind of like the lineage of these shapes. So if I do one more example, if I'm working over on the my far right side here, the right scalene triangle is also a scalene triangle, which is also a triangle, which is also a polygon. So this is really important because there's a lot of confusion with squares and rectangles. And so I want to make this really clear this morning right away before we jump into quadrilaterals that anything that is below another thing and is connected with a line means that all of them are that example. So if I go back to this one here, the obtuse isosceles triangles, it doesn't matter what the shape looks like. If it's an obtuse isosceles triangle, all of them are isosceles triangles. But not all isosceles triangles are obtuse. Some of them are acute, and some of them are even right isosceles triangles. Okay, so just do that a little bit, practice, go from bottom to top. Kind of take the path. So all right isosceles are isosceles, which are triangles, which are polygons. And it gets a little bit more complex when we start talking about the quadrilaterals. So what I want to do first is, I know we're not in class, I'd have you guys calling these things out. So we'll kind of do a little bit of make-believe here, all right? So just yell out any of the quadrilaterals that you know. Okay, I heard square. Yes, squares are an example of a quadrilateral. Give me another one. Pentagon. Nope. Pentagons have 5 sides, so that's not going to work. Rectangles. Yep, rectangles look a lot like squares. Okay, what else you got? Trapezoids. Sure. Yep, trapezoids are unique shapes. What else? Nope, not triangles. Triangles have 3 sides. So we said triangles have 3, pentagons have 5. We're looking at any shape that has 4 sides. Yep, there's that one that all of the sides are the same, but it kind of looks a little crooked. What you're talking about is a rhombus. When you were little, they probably called it a diamond. My daughter Audrey is playing with a lot of puzzles, and she's doing all these puzzles that they have this diamond shape on it. And I start telling her already, I'm like, well, we call it a rhombus when you get to math class. What else? Kites? Yep, a kite. Yep, you're right. Most people think of the noun for kite, like the thing that they're flying, but it's also a quadrilateral. What else? Parallelograms, that's another one. And anything else? No? I think you named them all. So if we start, I want you to go to your page number 225. So if you don't have your student book with you, push pause right now. Okay, got it? All right, welcome back. So what we're looking at here is another hierarchy, and this is the hierarchy of the quadrilaterals. So what we're going to do is I'm going to start you off with the hierarchy, putting these in the right spot, and then what you're going to do is you're going to go ahead and complete these student book pages for the day. So even though we're classifying quadrilaterals, this is just part 1 of this lesson. You're going to have part 2 next week, Tuesday, because Monday we don't have any learning time. So next week, Tuesday, you're going to do the second part of this. So if we start up at the top, any polygon that has 4 sides, you're going to write the word quadrilateral in there. Okay? Quadrilateral. So if you're looking at how to spell it, it's Q-U-A-D, quad, meaning 4, R-I-L-A-T-E-R-A-L, quadrilateral. Okay, perfect. So you're going to notice there are multiple types of quadrilaterals that fall underneath the second step. So with our triangles, we have equilateral, isosceles, and scaling. We're going to have 3 different types of quadrilaterals that are underneath any just normal quadrilateral. And again, they're all underneath polygons. So if we take a look, I'm looking at the far left of the page. It says a quadrilateral with exactly 1 pair of parallel sides. And that is called a trapezoid. T-R-A-P-E-Z-O-I-D is the spelling for that. So that's a trapezoid. And you'll notice, kind of like the equilateral triangle, how there's nothing underneath it. There's nothing underneath trapezoid. If you're looking at a shape and you want to name it in the most specific way possible, and it has 1 pair of parallel sides, it's a trapezoid. That's as specific as you can make that name. You also could call it a quadrilateral, or you could call it a polygon, because you can follow the path up. You can't follow the path down. The middle one, a quadrilateral with 2 pairs of parallel sides that are opposite of each other. That's going to be called a parallelogram. Right? Parallelogram is spelled P-A-R-A-L-L-E-L-O-G-R-A-M. Parallelogram. One to the far right, a quadrilateral that has 2 pairs of adjacent sides that are congruent. Wow, there's a lot of tough words in there. So let's break it down. First of all, adjacent simply means next to. So if you want to be real fancy, you can start calling your next door neighbor your adjacent neighbor. And then congruent means same size and same shape. All right? So adjacent meaning next to, congruent meaning same size and shape. So that's a kite, K-I-T-E. Then what you'll notice is there are some shapes underneath these, and so all of this shape, a parallelogram with 4 right angles, you could also classify them as parallelograms, or you could classify them as just a regular quadrilateral, because I can follow this path up. So the parallelogram that has 4 right angles is going to be a rectangle. So some people will call it a special kind of parallelogram. When you see parallelograms, a lot of times there's a very typical one. Let me just draw it for you real quickly up in here. You're going to kind of look at this shape like this, and all that happens is you straighten the angles into 90 degrees, and that is your rectangle that you have. Right? Then the one on the far right, a parallelogram or kite that has 4 congruent sides. So again, it has congruent sides, meaning that they're all the same length. That's going to be a rhombus, R-H-O-M-B-U-S. A lot of times people say it looks like a diamond. Okay, sure, but a diamond is not a mathematical shape. Some other people might say, ooh, it looks like a square that's just been tilted. Stop saying that, all right, because it's not really what it is. It is a parallelogram or a kite that has 4 congruent sides. All right, we talk about using our mathematical language. Use the word rhombus. Don't say it's a square that's tilted. Cut that out right now. All right, and then finally the last one at the bottom, the last one we haven't talked about, a parallelogram or a kite with 4 right angles and 4 congruent sides. That is like the pinnacle of quadrilaterals. That is the square, S-Q-U-A-R-E. That's a square. So what you're going to be doing is student book pages 225 to 227. We've already filled in most of it, but you need to go back and you need to sketch an example of what that's going to look like next to those. Do your best. This is where I'm going to be able to give you some feedback. Mr. Cerrone, Mrs. Brzezinski, Mrs. Stellenwerk will give you guys some feedback on your drawings and what you've created. And also at the same time, don't be afraid to use the internet. If you're like, wait, I'm not understanding what this kite looks like, Google it. Hate to say it, but go on and Google and say, hey, what does this kite look like? Be careful with that one because you're probably going to get a lot of pictures of the kites that you fly up in the air. Okay, so you have half of this page already done, so you're left with 226 and 227. Remember the important rule. You can go up, but you can't come down. So if I said that I have this parallelogram or kite that has four congruent sides, I would say this is that rhombus. A rhombus is also a kite, but not all kites are going to be rhombuses, because a rhombus could also have been a parallelogram. So you have to be careful. You can go up the path, you can't go from top to bottom. Okay? So that's your work for today, and then next week, Tuesday, we'll get to part 2 of this sorting of the quadrilaterals and understanding how we can classify them. All right? Always remember to upload your pictures, send those on to your teachers so that they can give you some feedback about the work that you're doing. So your work for today, again, just a reminder, 225 to 227. Have a great rest of your day, guys, and I look forward to hearing from you. See ya.